Okay, so welcome to another session. We'll continue from where we left in the last session. So today we'll talk about multiple things. Okay, the first topic that we're going to focus on is called data cube. Okay, why do we call it as data cube? Right, of course, with the word cube, you would have got some hint, right? We are talking about multi-dimensional thing. So a data cube helps us to represent data in multiple dimensions. Okay, it is defined by the dimensions and the facts. So dimensions are the entities with respect to which an enterprise preserves the record. Okay, so on this slide I have one example which is illustrated for you. So let's say there is a company called ABC. So this data is for company. Let me start my pointer. It's called ABC. Okay. So suppose ABC company wants to keep track of sales record, okay, with the help of sales data warehouse with respect to you have time, with respect to time, with respect to locations, and with respect to item types, right? And these are each of the item type: mouse, mobile, and modem. Okay. So these dimensions allow to keep track of monthly sales, okay, or rather quarterly sales, right? So in the example that we have is quarterly sales, but let's say it could be monthly sales or weekly sales, okay? At which branch items were sold and when. So there is a table associated with each dimension, right? Now this table, which is talking about each dimension, is called as dimension table. For example, if you focus only on item dimension, table items might have things like item name, item type, item brand. Okay, so we can have a table here which will have item ID, IID, item name, item type, item brand, right? And each of these items, let's suppose we have only two items, so it could be table of two items. Okay? Now, if you focus on the table which is represented here in the bold. Now, this is a two-dimensional table. Unlike this, which is one-dimensional, which talks only about item. But this table here, okay, talks about two-dimensional. Now, what are the two dimensions here? We have on x-axis, we have mouse, mobile, and modem. And on the y-axis, we have quarter, time. So this is the two-dimensional data of ABC company with respect to time and item. If you just focus on the highlighted part. Now, if you want to include one third dimension here, okay, so this is our third dimension, which talks about locations as well. So in actual, this data is for three-dimensional, right? But now if you just focus on the two-dimensional part, what you see here, okay, so what do we see? We see the mouse, modem, mouse, mobile, and modem for 4 quarters. Now, let's say, okay, we take Gurgaon as an example. Now, this data that you see is for Gurgaon, which means that in Gurgaon, in quarter one, there were 788 sales of mouse. There were 987 sales of mobile in quarter one in Gurgaon. Okay, so in this table we have records with respect to time and item only. The sales for, let's say, Gurgaon is shown with respect to time and item dimensions according to types of items sold. If you want to view the sales data with one more dimension, let's say we bring in the entire location into this picture, then the 3D view would be useful, right? The 3D view of the sales data with respect to time, item, and location is what could be shown in a bigger table, right? So, something like this maybe. So you can have three One is the common thing, let's say time. Time is common, Q1, Q2, Q3, so on. And then you can have here, you have three locations, right? So we can have data for three locations, which is Gurgaon, New Delhi, and Mumbai, right? And within each of these, you can have mouse, mobile modem, mouse, mobile modem, mouse, mobile modem, right? So this is how this cube can be represented on paper, okay? So your data cube represents data, okay, in multiple dimensions. This is what we meant, okay, when I say multiple dimensions. One single data, okay. So now let's move on. The next topic we're going to talk about is called data mart. Okay, so what is data? Data mart contains a subset of organization-wide data that is valuable to specific groups of people in an organization. Very specific to one group. Let's say sales data, or finance data, or HR data, or the product data, right? So in other words, the data mart contains only those data. I'm not talking about the entire data warehouse. Entire data warehouse will have all kinds of data. Within that, a subset of that, okay, which is specifically for a given department, okay, which has specifically has some related data, okay. So that is valuable to just a particular set of people. We call them as data mart. So in other words, data mart contains only those data that is specific to a group. Okay, for example, we have spoken about sales data. Let's say marketing data. We may contain only data related to items, customers, and sales. Data marts are confined to a few conditions. Okay, so um, so um, I don't have it here. Okay, so let's understand few things about data mart. Okay, so as I said, right, data marts are customized by department, specific department. And if you look at the size of the data mart, it is obviously much smaller than the total warehouse, right? You can have 10 different departments, 15, 20 different types of a data mart in a data warehouse. So obviously the size is 1/10 or 1/20th of the total warehouse. So size is less. Data marts are flexible. You can change the data. You can switch the data, increase, add a table to it, remove a table from it. Okay, and um, yeah, and if you look at the life cycle of data mart, they may be complex in long run. Okay, if we are not planning, if you have not planned and designed it well, okay. So generally, a data mart consists of data, this specific databases, which is again derived from main data warehouse only. Okay, so we could do it for multiple reasons. One, security. You want to secure. You don't want other departments to look at salary component. Let's say so you have HR department who has access to the salary department. So you want to restrict others. Okay, that could be one reason. Second reason is because accessing becomes much faster, right? You don't have to go through hundreds of table. Only have to go through tens of table in this case, right? Because you focus on marketing. So marketing, you'll have access only marketing data. So accessing becomes much faster, right? The third concept, okay, so this is the data warehouse architecture. Okay. Um, okay. So if you look at the architecture, this is where your data is stored at the bottommost. Okay. This is your data. You have external sources, you have operational databases. So data mart collects, or data warehousing collects data from multiple sources, right? And then you have to perform what we call as ETL. Okay, ETL, and you also have clean and transform. So you extract, transform, and then load to your data warehouse servers here, and this is where data marts are sitting. Okay, for monitoring you have different server, for administration you have different, for data marts or for data. So the job of the last row that you see your data is to just connect to different data sources and get the data ETL, okay, and then load into next level, which is your data mart, okay, or your operational data or data specific to specific work. Okay, so now data is actual data that you want to, which is cleaned, refined, ready to be used data. Okay, so this itself is another, there's a big team. When somebody says that I'm working on data warehousing, most likely this is where they are working. Okay, how to refine, get the data from multiple sources and put them in a refined and clean way. Then the output from this data is presented on the presentation layer. We call them as front end or the top tier. Okay, this is where the data is presented. Visualization, what we did in Tableau, Power BI, even in Python to visualize data is this, right? So we took this data and we create reports that are useful for the business. And how this data is going from database. Now, database could be sitting. Database could be sitting in one location in some server somewhere, in your home location, in head office, or or if you're putting on cloud, you don't even know where it is, right? In some countries, some data center data is present. And most probably you'll have one single copy, one single active copy. Okay, of course there are backups which are maintained so that in case when database crashes, you can easily switch on to the next database until that database is repaired and comes back online. So you do have fault tolerance and rollover mechanisms, but you have one database active, and the end user who's trying to who's working on the data will have access to the active user, and they create their reports, analysis, data mining kind of work. But how does data travel from this bottom tier to the top tier, or from data layer to your front end layer? Okay, that is managed by what is called as middle tier, or you have servers here, OLAP servers. Okay, OLAP we discussed before, right? OLTP versus OLAP, analytical processing. So online analytical processing servers job is to get the data from the data marts and other clean data to the front end, which could be used to design reports and tables. So as part of this, you have a data mart, which we have already seen. You have virtual warehouse and you have enterprise warehouse. So let's understand what is virtual warehouse and the enterprise warehouse. Okay, so your virtual warehouse, okay, is an view over an operational data warehouse. Okay, it is easy to build a virtual warehouse. Building a virtual warehouse requires excess capacity on your operational database server. So we are not talking about the analytical servers or data warehouse. Okay, it is actually your operational database, and there's a view that is created specifically to deal with the read aspect of the database. Okay, so that's the operational database, but it is your view which is just created. Okay, so to the user it looks like it is a warehouse, but it is actually not a warehouse. It is your live data. Okay, and we don't directly deal with the tables, but otherwise then the read operation or write operation will suffer, right? So that's why we have a view and we work with the view. Of course there will be some impact on the performance, so that's why it's not a preferred way. But then when you have small data to deal with, okay, um, okay, then this is a good idea, right? You don't have to create another setup for warehousing. Okay, now second type is called data mart, which we have seen. This is creating a subset of database. So you do have a warehouse and you create a subset of database and you use. Third type is enterprise warehouse, where you have everything, okay, as one warehouse. Okay. Now, so your OLAP, okay, online analytical processing server, is based on the multidimensional data model, which we have seen earlier. It allows managers of the data warehouses and the analysts to get an insight of the information through fast, consistent, and what we call as interactive access to information. We need access to information. Okay, so if you look at the different types of OLAP servers, we have four main types of OLAP servers. Those are your relational OLAP, okay, multidimensional OLAP, or also called as MOLAP, and hybrid OLAP, which is HOLAP. And then you have specialized SQL servers, which are designed to handle this kind of work, data warehousing kind of work. Okay. So your relational OLAP servers are placed between relational backend server and client front-end tools. To store and manage warehouse data, ROLAP uses relational or extended relations databases. Okay, so it's like implementing aggregation, navigation logic, optimization of each backend, database backend, and additional tools and services which is required. Okay, so that's about ROLAP servers. In multidimensional, okay, so they use array-based multidimensional storage engines for multidimensional views of data. With dimensional data stores, the storage utilization may be low if the data set is sparse. Therefore, many MOLAP servers use two levels of data storage representation to handle dense and sparse data sets. Okay, so hybrid OLAP is a combination of both ROLAP and MOLAP. Okay, that's what they're called as hybrid. Okay. The hybrid OLAP, okay, offers higher scalability compared to ROLAP and faster computation when you compare to MOLAP. And then, of course, you have specialized SQL servers. So they provide advanced query language, actually, advanced queries and advanced processing power to support for SQL queries, SQL queries over star and snowflake schemas in read-only environment. Now, if you talk about the OLAP operations itself, okay, since OLAP servers are based on multidimensional view of data, okay, we will focus our OLAP operations only in the multidimensional view. Okay, that's what we've been talking about, right? And there are four main types of OLAP operations. They are your roll up, drill down, slice and dice, and pivot. Let's see what each of these things mean. Okay, so roll up. Okay, roll up, right? So it is like aggregation, right? When you say roll up something, it means you're aggregating, right? You're combining things together. So roll up operation performs aggregation on data queue using, let's say, by climbing up a concept hierarchy of a dimension or by the dimension reduction itself. So if you look at this graph or the plot that you see here, the diagram, the roll-up is performed by climbing up a concept hierarchy for the dimension location. Okay, so you have this time here. Okay, so roll-up is so initially, if you see here, so you had street or let's say locations here, right? But when you roll up, okay, you're rolling up to countries, right? So let's say I manufacture pens, let's say, or masalas, or any manufacturer. Now, at different level of business operation, I need data for different levels, right? So now if I have, let's say I have a factory in one location and I need to send to all the stores across India, right? Now I need to understand, okay, how much demand each city is giving me. So the guy who's responsible for demand planning, or helping the demand planner, they are going to get data from multiple cities, right? So because ultimately when we build the product and when we ship it, we need to know how many product to send it to Delhi, how many product to send it to Hyderabad, to Mumbai, and so on, right? But in this case, you have examples of Vancouver, Toronto, New York, Chicago. So you need that data. But when you want to, when you are producing, right, you will add them all together, okay, and you make one data. So you roll up to make single data, because you want to produce, right? So you have only one production plant, right? So you need to know how many items to produce. So you are rolling up to one value, okay, which is entire thing, and then you'll tell you. But let's say if you have a team who is responsible for distribution, now they need to know how many countries you are sending it to. Let's say if a factory is in the US, then to send it to Canada, you might need to have some kind of export agreement, right? So it could be a different game altogether. So you want to know how many products I need to export to Canada, how many products I need to export to Africa, okay, how many products I need to distribute within the country, right? So you will have to roll up same data. So you are combining, let's say in this case, Chicago and New York together for the US, and Vancouver and Toronto together for Canada. So that's called roll up. You are adding few columns together to represent a new column, right? So if you talk about a retail store, it can become much more complex, right? If you talk about Walmart, Walmart needs to know which item to send it at which store, right? So they need to know details of each item at each store with store ID. But when they're planning, they plan at region level, right? So in that particular region, all the data, all the information, you will roll up to that level. Okay. So basically what I'm trying to say is that when you add certain columns together and create a new column, you are rolling up, you're going one step above. Okay. And the next one is called drill down, and drill down is exactly opposite of that. Okay. You are expanding. Let's say you have data at annual level. You want to drill down to quarter level. You have to drill down to month level. And we have seen this in interview, right? How we actually drill down to quarter to month level, right? So this is how you will drill down. Okay. So it's actually, as I said, is reverse. Okay. And you are introducing new dimension here again, which is a smaller dimension of the larger one. So it could be like on time, for example, for time, it could be sorry, annual to quarter to monthly. For location, it could be from region to states to cities. Okay. For product, it could be product to product variety. Each of the product variety, like mouse, then you have black color mouse, blue color mouse, pink color mouse. So you are drilling it down, right? So again, drill down is performed by stepping down a concept hierarchy for the dimension time. In this case, we're looking at specifically uh, here quarter is getting converted into month. So we are drilling it down to time, right? So here we are navigating from less detailed data to highly detailed data. Otherwise, in roll up, it was It was like highly detailed data to, or rather, high detailed data to less detailed data. Now here we are expanding the details. This is called drill down operation. The next is called slice. Okay, so slice. Okay, so there's no drill down or drill up in this roll up. There's no roll up or drill down. We are looking at the same set of values, same size of values. Here also you see you have 4 cities, and here also you have 4 cities. What you see here is that we are just taking a portion of it. So there's no new dimension which is getting introduced. In other 2 steps that we have seen, other 2 types, we have seen there's a new dimension which is getting stored, created. Whether you are rolling up from cities to state or countries, from quarter to year, or from year to quarter, you're creating a new dimension. Here, there's no new dimension. So slice operation selects one particular dimension. In this example, you have location. Okay, is it location? No, it's time, right? It's time. So you select one particular dimension from a given cube, right? Data cube, and provides a new subcube. It is still a subcube. Okay. So here, slice is performed for the dimension time using the criteria time equal to Q1. So when time equal to Q1, you get only a slice of the entire data. Okay, slice that matches the condition, which is quarter equal to 1. And it will form a subcube, okay, by selecting one or more dimension. And then you have dice. So we said slice and dice. That was the slice, and this is dice. So dice selects 2 or more dimension from a given cube and provides a new subcube. So this is also like providing new subcube, right? But it selects 2 or more dimensions here. Okay. So this example, if you see, I'll give you a few seconds to look at it. So this is the main data. So we have, the items, the locations, and your timeline. Now we are slicing on location equal to and time equal to. So you are slicing on both row and column. In the sense, you are slicing on more than one dimension, 2 dimension. Okay, earlier we had only one, so it's called slice. Dice is when you are dicing on more than 2 location, right? So it's called dice. So similar to slice, but slice will have 1 dimension, dice will have more than 1 dimension. Okay, the next one is called pivot. The pivot operation is also known as rotation. You are rotating it. That rotates the data axis in view in order to provide an alternative presentation of data. Okay. So, for example, if you see, you have cities here. You have Chicago, New York, Toronto, and Vancouver. Okay. And now what I'm doing, I'm putting this one, which is an x-axis to y-axis. And what was on x-axis, we are putting down to y-axis. So, so you are changing. Okay, you are rotating. Okay, this is what we call it as pivot. Okay, so so data warehousing, relational OLAP. What is relational OLAP? Okay. Relational OLAP servers are placed between relational backend servers and the client frontend. We saw those 4 tier, right? To store and manage the warehouse data. The relational OLAP uses relational or extended relational database management system. Okay. So here generally we talk about implementation of aggregation logic, optimization of each database backend where data is actually stored, and tools that we need to use. Just few things that you need to remember is rollup servers are highly scalable. Okay, and the tools analyze large volumes of data across multiple dimensions. Rollup tools store, analyze highly volatile and changeable data as well. Okay, and If you look at the architecture of Rollup, okay, so you can see here we have a database server. This is the backend, right, where data is stored. Then you have the server that I was talking about. Okay, and finally, the server will send the result, okay, to the front end tool. Okay, so rollup servers can easily be used with existing database system, and it can store efficiently with zero facts. Okay, you don't need to have facts. And rollup tools do not use pre-calculated data cubes as well, direct from the database server. Okay, um, and this advantage, disadvantages also, right? Because since there's directly, okay, there's a query performance is poor, slow here. Okay, and then you can even find some limitations of scalability depending upon the technology. Okay, that the architecture that is being utilized. Okay, so that was about rollup. Now we'll talk about molap. Multidimensional lab servers uses array-based multidimensional storage engines for multidimensional views, okay, of the data. With multidimensional data storage, the storage utilization may be low if the data set is sparse, right? So most of the cells will be blank. Okay, therefore, many MATLAB servers use two levels of data storage representation to handle dense and sparse, the sparse data sets. So let's say, we create similar kind of data that we had earlier. And let's say, you have data for Q1 and Q2, but you don't have data for Q3 and Q4. And you don't have data for a specific city. And you don't have data for a specific item. Okay. So a lot of the cells here will be empty. And that will occupy a lot of space just because you are following the multidimensional format, right? Multidimensional format is good when you have very less missing data so that all the cells are used. It's like it's like arranging the chairs without people sitting on the chair, right? So you take and if you arrange 10 by 10, if you have only 10 people, and if you are arranging 10 by 10 chairs, so 90 chairs will be you know left vacant, right? And it uses a lot of resources. You need big room, you need chairs and things like that. Instead, if you have a smaller room, right, with fewer chairs, it is easy to manage the data, correct? So the way data is handled densely and sparsely data set is different in Mulab. And the way it is designed is for a faster um, query performance. So where if when you have a lot of data and you want it to be run faster, there is nothing better than Molap. So let's look at the Molap architecture. Okay, not much different than Rolab, right? You have a server and it does the metadata request processing. Okay, the advantage, as I said, it is nicely indexed and speed of the query is faster. Okay, and disadvantage is that because of the structure, it is not capable of containing large data or detailed data. Not sorry, not large data, but detailed data. Okay, the next one is called schemas. Okay, what is a schema? So schema is a logical description of the entire database, right? It includes name and description of records of all record types, including all associated data items and aggregates. Much like a database, a data warehouse also requires to maintain a schema. Okay? The same concept that we discussed in our OLTP exercise or the operational database exercise. A database uses relational model with a data warehouse uses star, snowflake, fact, constellation schema, right? So we'll talk about different schemas that we have. Okay, the first schema is called star schema. Each dimension in a star schema is represented with only one dimensional table. Always one dimensional table. You have, for example, you have sales and the columns of sales. That's a separate table. Okay, branch is a separate table. Location, item, sales, all are separate table. So there's a fact table which is at the center, and you have dimension table around it. Okay, that's called star schema. So the dimension table will have the values here. Okay, and your fact table is at the center, and it has keys. Okay, it has keys to each of the dimension table. So time and item is connected using the fact table. So you have time. Okay, so for example, if you see uh, location, right? Location, branch, type, and um, time. These are the dimension table which has the actual data, and you have sales data which is collection of all this data. Okay, so if you see here, each dimension has only one dimension table, and each table holds a set of attributes, right? So for example, time has attributes like time key, which is the primary key of the table. Then you have day of the week, month, quarter, year. Okay, so this is how your star schema looks like. Now this is snowflake schema. The snowflake schema, still you see there is a fact table and you have dimension table connecting to it. Okay, very much like star schema, but with some additional thing. There's a extra part here. Okay, the extra part is that the tables in Snowflake are normalized, like your database in operational database kind of structure or OLTP structure. Your tables have to be optimized, sorry, normalized. When you create normalized, okay, you might end up creating multiple tables, right? And then your table can extend another table. So normalization split up the data into additional tables. Unlike star schema, the original, the item description table in star schema is normalized and split into two-dimension table. Okay, so if you talk about employee can be again broken down into employee and department tables, right? That's called snowflake. Okay, so because of normalization, the snowflake schema redundancy is reduced. Okay, redundancy is reduced. Redundancy is actually encouraged when you have star schema. Okay, you don't want to create a dependent table, but now, okay. So due to normalization here, right, redundancy is reduced and it becomes easy to maintain and save storage space, right? Because normalization, again, you don't add duplicate values, right? So your storage space is saved. Then you have fact constellation schema. Okay, so you have a fact table here, and then you have one dimensional, okay, shipping item, and then time is also linked to this, right? So conservation schema has multiple facts table, just like no, okay. um, it does have multiple fact table, okay, and we call them as galaxy schema as well, okay, because it has multiple fact table. Okay, so if you look at this table here, it's an example of your sales and shipping data. Okay, sales and shipping data. The sales table is same as the star schema, right? Sales, there is no change here. But the shipping fact table has 5 dimensions, right? Which is here your item key, time item, okay, time key from where, um, you know, uh, So I was talking about time key, then you have shipper key here, right? Then from location and to location. The shipping fact table also contains two measures, that is your dollar and units sold. Okay. It is also possible to share dimension tables between fact tables. Okay. So for example, if you look at time here or even item and location dimension tables are shared between sales and the shipping fact table. So you are sharing it with another table. This is called as fact constellation table. Okay. So with that, we complete the basic of data warehousing also. I'm going to um, upload my notes as well to the same location where this video is uploaded. And yeah, with that, we come to the end of our session. Okay. Thank you so much, everyone. And we'll see you soon. All the best to everyone. All the best. Bye. Take care.